Hi, this is Nikhil. I'm working as an application engineer in Tektronix India. Here I have a video for the 6 series and 5 series oscilloscope, which are having a logic analyzer capabilities inbuilt. So how we can use those logic analyzer capability without having a dedicated logic analyzer for the applications. So here I have a setup for the same using a 6 series MSOs, and I'm using right now one TLP 058 probe, and along with that I have this demo board which I'm using for the signal generation. So as you can see here, I have a counter which is rightly I have used flying lead probes as target, which we are probing it and going to do an analysis over it. So let's get started. What I'm doing is I'm just going to hook up this TLP 058 probe. The moment, as you can see, is the TLP is hooked up to the any of the analog channel, it is automatically consider or takes that channel as a logic analyzer capability or the logic signal capability. So now as you can see here, we have a lot of signals which are roaming around, and I'm just trying to squeeze in the time base range so we can see that. Alright, so as you can see, there are a lot of activity which is happening. I have rightly probed the clock which is on D0, and from D1 to D7 is nothing but the data channel which is which are available over here, which is probed from the counter. For normal logic analyzer analysis, there are two type of analysis available, which is one is asynchronous analysis, the other one is synchronous analysis. Asynchronous analysis is nothing but you're going to use the oscilloscope or logic analyzer's clock to do a sampling, and that will help you to do more of a glitch analysis. So as you can see it here rightly, we are seeing a lot of component which are like narrow place. Let me just stop it. We can see here, right, this is what nothing but the timing analysis. We are using MSO6 is having a capability of doing a sampling of 25 gigasamples per second on the logic channel as well, so we can detect any of the glitches is as narrow as like 40 picosecond resolution. So let's get started. I can create say add new bus. So this will help me to create, say I have a parallel bus, and right now I'm using there is no clock data. So first we are just going to see as an asynchronous analysis. Here I have to define the input which is available. So what I'm doing is I'm just trying to put up every other data, say right, and this is also having an individual threshold selection that will help to recreate the same as a logic analyzer. Logic analyzer is always having a per channel threshold setup. 6 series and 5 series MSOs are also giving you the per channel threshold setup right over here. Once done, as you can see it, there is a parallel bus which is created over here. Let's zoom in into the portion and can see the data which is flowing inside it. So as you can see it, these are sampled with asynchronous, so you can see there is no relevancy of the data counter as it should be. It is rightly over here because we are not providing oscilloscope the reference where it should start sample. So the moment we go into the result table and say bus decode, and this will help you to do the bus decoding setup. As we can see it here, the data which is completely not as a working as a counter, though we have probe onto the counter. So this is what the normal asynchronous analysis is. This will help you to more of detect the glitches which is right over here. So let's zoom into the one of the glitch which is right over here. So as you can see here, there is a glitch, very narrow pulse width which is there. And that corresponds to the specific data which is changing the bus. Right, so that's what the asynchronous analysis is. Now if you want to do a state analysis or more of a synchronous analysis, the 5 series and 6 series gives you the feature called clocked data, which will help you to say that I have, yes, the clock available which I am providing to the scope for the sampling purpose, and now I have to give where the clock is, and that, as you know, like we have probed the clock onto the D0. So I have just selected the D0 and I can put up the threshold setup over here, and let me just see, I can redefine the buzz, and I have this 6 as 7 as a data width of the counter, and now I'm just rerunning the setup, and let me just trigger onto the channel 1 and just say I'm just triggering on D7. Right, so now you can see the data is exactly working as encounters. Say starting from, you will have data which is 2 C D E F 30, then 3 1 3 2 and so on. However you want to do any of the packet, you can just click and it will automatically navigate to the particular packet over there. Suppose I want to find out, say I want to go on to the 54, so it, as you can see, is directly route onto the 54 of the data. Such way you can have a complete counter data. This you can export, and this is the way you can also utilize the 6 series and 5 series or 4 series, and there are other like 70,000 and 4000 series scopes as a logic analyzer as well. Yeah, thank you for watching.